All right, welcome back, everyone. Ready for another deep dive.
Oh, absolutely. Always ready to explore something new. Or in this case, something pretty old, celestially speaking.
Yeah, today we're going back in time a bit. Going to look
Huh.
back at a story that had everyone holding their breath a while back. Asteroid 2013 TV-135.
Ah, yes. 2013 TV-135. The asteroid that, for a short while, had us all wondering if 2032 is going to be, well, a little more exciting than planned.
Definitely more exciting, maybe a bit too exciting, right? I mean, those headlines were pretty dramatic back then. Huge asteroid, potential Earth impact, the whole 9 yards. So let's rewind and unpack all that, starting with the star of the show, the asteroid itself. What are we dealing with exactly? Size, speed, the kind of stuff that makes you go, whoa.
Okay, picture this. We've got this rock basically hurtling through space. And it's not just any rock. This thing is about 400 meters in diameter. To put that in perspective, imagine 4 football fields, end to end. That's the size of this asteroid.
Whoa, that's a pretty big rock. And it's moving pretty fast too, right?
Oh yeah, this thing is zipping through space at a casual 50,400 kilometers per hour. That translates to about, let me see, over 14 kilometers every single second.
See, that's what I mean by whoa. Okay, so we've got a big, fast-moving space rock. And if I remember right, it got tagged with some, let's say, attention-grabbing labels. Near-Earth object and potentially hazardous asteroid.
You're right on the money. Those terms definitely made everyone sit up and take notice. I mean, just hearing near-Earth objects is kind of self-explanatory, right?
Yeah, it means it's like in our cosmic neighborhood.
Exactly. An NEO is any asteroid whose orbit brings it relatively close to Earth's orbit. Now, just because something's a neighbor doesn't mean it's going to crash your party, right?
Right, so what about that potentially hazardous part?
Okay, so that's where things get a little more serious. It's not just about proximity. A potentially hazardous asteroid, or PHA, is one that's big enough, usually over 140 meters in diameter, and its orbit comes close enough to Earth's that, well, an impact could cause, let's just say, significant damage.
Okay, so 2013 TD-135 fit both those descriptions, big and close to Earth. And then came the initial calculations suggesting a possible impact in 2032. I mean, what were the odds they gave at that time?
The early estimates put the chances of an impact at about 1 in 63,000. Not exactly a sure thing, but enough to raise eyebrows in the scientific community. And, it even got a level 1 rating on the Torino scale.
The Torino scale, that's like a threat level system for asteroids, right?
Exactly. It's a way for scientists to categorize the potential danger posed by asteroids and comets. A level 1 rating means you got to keep an eye on it, monitor it closely, but it doesn't mean panic stations just yet.
Okay, so at this point, I think our listeners are probably wondering, what if it had hit? Like, what kind of damage are we talking about? Paint us a picture of that hypothetical scenario.
All right, so buckle up, because it wouldn't have been pretty. The projections at that time, based on the size and speed of 2013 TV-135, were estimating an energy release equivalent to, get this, 2,500 megatons of TNT.
2,500 megatons of TNT.
Right.
Okay, I'm going to need some context for that.
To give you some perspective, that's 50 times more powerful than the largest nuclear weapon ever detonated. So anything directly in the impact zone, well, it would be pretty much instantaneous devastation.
Wow, and we're just talking about the immediate impact zone, right?
Right, but the effects would go way beyond that. We'd be looking at shock waves, massive fires, potentially even triggering earthquakes and volcanic eruptions depending on where it hit. And if it landed in the ocean, well, forget about it. Colossal tsunamis, hundreds of feet high, sweeping across coastlines, and all that dust and debris thrown into the atmosphere, it would blanket the planet, disrupt weather patterns, potentially cause a global cooling effect. We're talking about consequences that would be felt for years across the globe.
That's a pretty chilling scenario.
Yeah.
So how did we go from brace for impact to, okay, we're good? How did they finally determine that 2013 TV-135 wasn't going to hit us after all?
It really comes down to the nature of science, right? The initial predictions were based on a limited set of observations. As more data was gathered, more eyes on the skies, agencies like NASA and the European Space Agency, they were able to refine their calculations. They got a clearer picture of 2013 TV-135's trajectory, and eventually those refined observations showed that, thankfully, the risk of impact was pretty much non-existent, like a big sigh of relief across the planet.
A huge GE sigh of relief, I bet.
Yeah.
But even though it turned out to be a false alarm, Did this whole episode with 2013 TV-135 have any lasting impact on, how we approach the whole planetary defense thing?
Absolutely. It was a wake-up call, a reminder that, we're not alone out here. There are these celestial objects whizzing around, and some of them, well, they could pose a threat. And 2013 TV-135 really got people talking about planetary defense and, more importantly, investing in it.
So what does that look like, practically speaking? What kind of strategies are being developed to, protect our planet from these potential asteroid threats?
Okay, so we're talking about a multi-pronged approach. First off, constant vigilance. That means having programs like NASA's Near-Earth Object Program, which is dedicated to, scanning the skies, identifying and tracking potentially hazardous objects, basically keeping a close eye on anything that comes close.
Right, so early detection is key. But what happens if we find something that eyes on a collision course?
That's where the next step comes in, developing deflection technologies. And we're not just talking theory here, we're actually testing these things out. Take NASA's DART mission, the Double Asteroid Redirection Test. They intentionally crashed a spacecraft into an asteroid, and you know what? It worked. They actually managed to change the asteroid's trajectory.
Yeah, the DART mission was incredible. It felt like something straight out of a sci-fi movie, but it was real.
Exactly. It shows that we're not just sitting ducks here. We're actually developing the tools and techniques to potentially deflect an asteroid if we need to. And another crucial part of all this is, of course, international cooperation. Space agencies around the world, they're all working together, sharing data, coordinating their efforts to make sure we have a truly global response system in place.
It's amazing, isn't it? It really feels like we're stepping up, taking responsibility for protecting our planet. It's kind of inspiring in a way.
Definitely. It shows what we can achieve when we work together, facing a common challenge. And it really does make you appreciate the incredible work being done by scientists and engineers all over the world to keep us safe. But of course, even with all our advancements, it still makes you wonder, what else is out there?
Yeah, and are we truly ready for whatever the universe might throw at us next?
Big questions to ponder. And those are exactly the questions that are driving ongoing research and innovation in the field of planetary defense. So stay curious, folks.
Absolutely. And on that note, thanks for joining us for another deep dive. We'll catch you next time.
Until then, keep looking up. And maybe keep an eye out for those asteroids, just in case.